Hello dear students, welcome back to your physics class. I'm back again with another video. Today's video, we are going to solve the questions of the section review in chapter 2, section 3, and we are going to solve the questions of the test prep at the end of the chapter 2. As you know, in the previous lesson, we stopped here. Question 1 in section review 2-3. A student holds a 3 kilogram mass in each hand while sitting on a rotating stool. Okay, as you can see in this figure, the student holds 3 kilogram mass. This is 3 kilogram and this is 3 kilogram. Two dumbbells. Okay, sitting on a rotating stool. When his arms are extended horizontally, it means that at this moment of inertia increases. Okay, so the masses are 1 meter from the axis of rotation, and he rotates with an angular speed of 0.75 radian per second. So this is correct. This is the mass. It should be mass, not student. Okay, correct this mistake, please. Okay, how many masses do we have in this question? 2 mass, 2 dumbbells that holds by the student. Okay, we have to add up the 2 masses, okay, which is equal to 6 kilogram. The mass is 1 meter from the axis of rotation. It means that R initial is 1 meter from the axis of rotation, and it is angular speed omega initial is equal to 0.75 radian per second. If the student pulls the masses horizontally to 0.3 from 1 meter to 0.3 from his body, it means that R final decreased from 1 meter to 0.3 meter. What happened to the R decreased? When R decreases, moment of inertia also decreases, but it is angular speed must be increased. Okay, it is initial angular speed of the mass is 0.75 radian per second, but it is final angular speed must be bigger than this number. Look, 1.9 radian per second. Why? Because the radius decreased and moment of inertia also decreased, but it is angular speed increased, so the angular momentum is conserved. What is his new angular speed? Assume that the combined moment of inertia for both student and the stool is 3 kilogram dot meter square. What is this? This is the moment of inertia for the rotating stool and the student. The moment of inertia for both the student and the rotating stool are given in this question, which is equal to 3 kilogram meter square. Okay, because the angular momentum is conserved, initial angular momentum is equal to final angular momentum. Okay, and I initial for the mass plus I initial for the stool on the rotating stool or geometric shape times initial angular speed is equal to I final for the mass plus I final for the stool times omega final, unknown. Okay, now we have to find the moment of inertia for the mass one by one. I initial for the mass this is not student, this is mistake, please correct this mistake. This is for the object, I mean for the mass. For the 2 masses or for the masses, I initial is equal to MR initial MR initial square. Mass, the 2 masses are equal and is equal to 6 kilogram times R initial 1 meter. 6 times 1 is equal to 6 kilogram meter square. What is this? This is the initial moment of inertia for what? For the 2 masses, for the 2 dumbbells. Okay, each mass has 3 kilogram. I final mr final square, because the student tried to close his hand inward, cutting moment of inertia. Mass is the same, time is r, and r final was given 0.3 meter. Okay, is equal to 0.3. Sorry, this is 6 times 1, should be square. Okay, 0.3 square is equal to 0.54 kilogram meter square. So I initial and is equal to I final for the stool and the student, which is equal to 3 kilogram meter square. Okay, what is unknown? Omega final. Omega final, this 2 term goes to the denominator. I final for the mass plus I final for the stool and the student, and over this ratio we have I initial for the mass plus I, the moment of inertia, initial moment of inertia for the stool, times omega initial. Now replace I initial for the mass. We found 6 plus 3 and 6 plus, sorry, this is not 6. This is 6 plus 3, yeah. And final moment of inertia for the student, for the mass, sorry, for mass is equal to 0.54 plus 3 times initial angular speed was given 0.75. So in that case, by calculator, omega final is equal to 1.9 radian per second. As I told you before, the final angular speed must be increased. Why? Because the student tried to close his arms toward his body, or cutting, in that case, cutting moment of inertia. So the cutting moment of inertia, it means that the decreasing of moment of inertia and its angular speed must be decreased, because its angular momentum is conserved. Okay? This is question 1 in section review. Now we're going to solve question 2. Very good question. Question 2, it has been brought in the Wizaria exam many times. Careful, guys. Okay? Question 2, physics in action. A bicyclist exerts a constant force of 14 Newton. This is the exerted force. 40 Newton. Okay? On a pedal, 0.15 meter from the axis. So the distance from axis of rotation is 0.15 meter. Okay? Of a bicycle with the radius the radius of the bicycle tire 0.5 meter. 50 centimeter, you have to convert to meter, which is equal to 0.5 meter. If his speed is 2.25 meter per second, this is the linear speed of the bicycle tire, 2.25 meter per second. 3 seconds after time, 3 seconds after he starts from rest, this is V final and V initial. It is 0 because it started from rest. What is the moment of inertia of the wheel? What is unknown? The moment of inertia of the wheel. Okay? So, how can you determine the moment of inertia of the wheel? The moment of inertia of the wheel is equal to mr squared. Do we have r? Yes. The radius of the tire was given 0.5. But do we have mass of the wheel? No. So that is why we cannot use this relation. Be careful. You cannot use this relation to find moment of inertia of the wheel. So that is why you have to think about another equation. Another equation that includes the moment of inertia is the Newton's second law for rotational motion. What is the Newton's second law for rotational motion? Net torque is equal to I alpha. Okay, so you have to rearrange this equation. I is equal to what? I is equal to what? Net torque over angular acceleration. Okay, now do we have net torque? No. Net torque is equal to what? Is equal to F times D. Force was given for T that exerted on the pedal times the distance of the pedal from the axis of rotation is 0.15, okay, which is equal to 4.5 Newton meter. Alpha, do we have alpha? No, this is torque. Alpha, but we can find it. Omega final minus omega initial over time. Do we have omega final? Yes, was given. Sorry, we didn't have. But we can find it. Omega final, there is a relation between omega final and final angular speed. Omega final is equal to what? V final over R. V final 2.25 divided by 0.5, as you can see here. Sorry, this is not, okay. This is 4.5 omega final is equal to 4.5 radian per second. Okay, radian per second. So, like calculator, you can replace here 4.5 minus 0 divided by 3. Alpha is equal to what? 1.5 radian per second square. 40 times 0.5 is equal to what? 0.15, sorry, is equal to 6 Newton meter. Now, replace into this equation. Net torque, I found it, 6, alpha 1.5. So, moment of inertia is equal to what? Is equal to 4 kilogram meter square. Look, 4 kilogram meter square. It's a very good question and it's a very easy question. Be careful. This is the force of the pedal that exerting on the pedal. It is axis of rotation. This is 0.15 meter, and this is the radius of the bicycle tire, and the moment of inertia is equal to 4 kilogram meter square. Another question. Actually, I added this question. This is not in the section review, but it is a very good question, so that is why I wrote here. If a rotational kinetic energy of an object is 200 joule, what is this? Rotational kinetic energy, okay, for this object is rotational kinetic energy, 200 joule, okay, and it is angular momentum L is equal to 40 kilogram meter square second square, okay. What is angular speed? Because the angular momentum is given in this question, it means that it is angular momentum is constant. So when the angular momentum is constant, you have to use this relation. Rotational kinetic energy is equal to 1 over 2 L omega. Okay, so you can rearrange this equation to find omega. Okay. The moment of angular momentum is going to the denominator, 2 times rotational kinetic energy. 2 times 200 divided by 40, okay? This 0 cancel, okay? 20 divided by 4, 5, 2 times 5 is equal to 10. So angular speed is equal to what? So you can write down 2 times 20 is 40 divided by 4 is equal to 10 radian per second. This is the angular speed for this object. Okay, so you have to write down the equation of rotational kinetic energy, I omega, but I omega is equal to L. So that is why you can rearrange to find the angular speed. Okay, so the escape speed has skipped by the Ministry of Education. Okay, also this notice skipped all information about the black hole and the escape speed has been skipped. Okay, this is not included for the Visario exam. Okay, now let's solve the questions of standardized test prep of chapter 2. It is very important, please pay attention for the questions of standardized test prep. Look at question 1. 3 forces acting on the wheel above have equal magnitude. Which force will produce the greatest torque? How many forces do we have? We have 3 forces here. All forces acting on the same point. The same point, the same distance from axis of rotation, but with different angle. Okay? Which force produces the greatest torque? Absolutely F1. Why? Because F1 is perpendicular to the axis of rotation, to the distance from the axis of rotation. So that is why torque number 1 is bigger than torque 2, bigger than torque 3. Actually, F3 has no torque. Torque number 3 is equal to 0. Why? Because it is parallel to the axis of rotation. So the correct answer is F1. Okay? If each force is 6 Newton, angle between F1 and F2 is 60, and the radius of the wheel is 1 meter, what is the resultant torque? To find the resultant torque, in this case, net torque is equal to torque number 1, number 2, number 3. Now we have to find one by one, okay? Torque number 1. Torque number 1 is equal to F1 D1 sine theta 1, okay? F1 6 Newton times D 1 meter sine 90 is equal to 1 is equal to 6 Newton meter. What is this? This is torque number 1. Number 2, F2 D2 sine theta 2. F2 6 Newton, D 1 meter, sine the angle between F1 and F2 is given. Okay, so it is this angle, yes, 60 degree, but actually we don't need this angle, because in the equation of the torque, when we say FD sine theta, this angle, it should be between force and the distance from axis of rotation. This is from force to the axis of rotation. This angle, which was given in this question, is between F2 and F1. This angle is not between F and D. So that is why we have to convert this angle from F2 to the distance from axis of rotation. So that is why you have to convert this angle 60. If here we have 60 degree, in this here we have 30 degree. Why? Because right angle is 90. 90 minus 60 is equal to 30. So that is why we have to use sine 30. Torque number 2 is equal to 6 times 0.5 is equal to 3 Newton meter. Okay. Torque number 3 is equal to F3 D3 sine 0. Sine 0 is 0 times force times D is equal to 0 Newton meter. Okay. Torque number 2 3 and 0. 6 plus 3 is equal to 9. Okay. Because the force is acting like that. Okay. So this is counterclockwise. Also this is counterclockwise. That is why it should be positive. The net torque is positive. Why? Because all forces acting on the wheel with the counterclockwise direction. Okay. About this angle, I'm gonna again, please. This angle was given 60 degree, but actually we don't need this angle. We need the angle between force and distance from the axis of rotation. This is distance from the axis of rotation. We need this angle. If this angle is 60 degree, this angle becomes 30 degree. Okay. If the same torque is applied to 2 pulleys, how many pulleys do we have? 2 pulleys. Okay. We have 2 pulleys of the same diameter to rotate with different angular speed. Okay. With different what? Angular speed. How many pulleys do you have? Two. Number one, number two. They have the same diameter. It means that they have the same radius. R1 is equal to R2. Okay. So torque number one is equal to torque number two. Okay. To rotate with a different angular speed. But omega 1 is not equal to omega 2. So M1 is not equal to M2. Moment of inertia number one is not equal to the moment of inertia for the second one. Okay? Look, because they don't have the same angular speed, so the angular speed is directly proportional to the rotational kinetic energy, so that is why rotational kinetic energy number one is not equal to rotational kinetic energy number two. Their moment of inertia are different? Yes, their moment of inertia must be different. So this question 3, has a mistake. You have to correct this mistake, okay? In the question 3, two options are correct. Be careful. Option A and option C are correct, okay? Their moment of inertia are different. Yes, of course. Why? Because the question mentioned only the radius the same, diameter is the same, not mass, okay? So their moment of inertia are equal? No, their moment of inertia is not equal, okay? So that is why this is incorrect. Their rotational kinetic energy are different? Yes. Why? Because the question mentioned that it is angular speed are different. Different angular speed, it means that they have different rotational kinetic energy. Okay? So when does rotational kinetic energy becomes equal? If the angular speed and the moment of inertia are the same. Their rotational kinetic energy are equal? No, not equal. So in this question, option A and option C are correct. Be careful. Which rotational quantity is the equivalent to mass in translational motion? Moment of inertia. The rotational analog of mass is moment of inertia. Question 4, C is correct. A force of a magnitude 2 Newton is applied tangentially to a disc, of a mass 5 kilogram and radius 0.1 meter. What is the angular acceleration of the disc? Newton's second law is equal to I alpha. Alpha is equal to what? Torque over moment of inertia. Torque, was given. Torque was not given, but the force applied tangentially to the disc, F D over, for the disc has moment of inertia 1 over 2 F R squared. Force was given 2 Newton. The distance from axis of rotation 1 meter. 1 over 2 times 5 kilogram disc, yes. Time is 0.1 square, which is equal to 8 radian per second square. Okay? 8 radian per second square. So, question number 6. A man of a weight 720 Newton stands on the light board of the length 2 meter. This is the length of the board, 2 meter. That is fixed on the two supporters at its extremities, okay? Supported by 2 pillars at each end, okay? So, if the distance between the point where the man stands and the first support is 0.5 meter, this is F1, first support, and this is F2. If the man stands 0.5 meter, this is the man stand is 0.5 meter from this. So its weight is Fg of the man is 720 Newton. Okay? What is the force exerted by the first support on the board? By the first support on the board. F1 is unknown. If F1 is unknown, we have to make F2 as the axis of rotation. Without axis of rotation, you cannot solve the question. The selection of the axis of rotation is arbitrary. It's up to you. Why we have to make F2 as the axis of rotation? Because F1 is unknown. To find F1, F2, it should becomes the axis of rotation. But to find F2, you have to make F1 as an axis of rotation. Okay? So in that case, to find F1, we have to use the rotational equilibrium, which is equal to 0. The torque is that acting upward is equal to all torque is that acting downward. Okay? For the upward, we have two force F1 D1 plus F2 D2 is equal to FG1 D1. Okay? So now F1 is unknown. D1 from axis of rotation, this distance is 2 meters. Okay? 2 plus F2 times 0. F2 because located on the axis of rotation, so that is why it is distance from axis of rotation is 0. FG1 720 times, if here we have 0.5 meter, what we have here 1.5. Why? Because 1.5 plus 0.5 is equal to what? 2 meter. Here we have 0.5 meter, but here we have 1.5 meter because the entire beam is 2 meter. Okay, 1.5. This is cancel and F1. This 2 is goes denominator. 720 times 1.5 is equal to what? 540 Newton. This is the force that exerted by the first pillar to the beam. Okay. Question number 7. A disc of mass 0.5 kilogram and radius 0.1 meter. Mass 0.5, radius 0.1 meter. Without slipping on an inclined plane, what is the total kinetic energy of the disc? What is unknown? The total kinetic energy of the disc. For what? For disc. Okay? At the instant y and the instantaneous speed v is equal to 1 meter per second. How can you determine the total kinetic energy? Total kinetic energy it means that the summation of translation and rotational kinetic energy. Total kinetic energy is equal to, translation is equal to 1 over 2 mv squared plus 1 over 2 I omega squared. Bring down this 1 over 2 mv squared plus 1 over 2 times. And instead of I for the disc, you have to write down what? 1 over 2 mr squared. And instead, this is for the disc. And it is angular speed is equal to v squared over r squared. Okay, r with r cancel. What does remain? 1 over 2 mv squared plus 1 over 2 times 1 over 2, 1 over 4 mv squared. Okay, because they have the same term according to math basic, we have to add out this two term. 1.2 plus 1.4, lowest common factor 4, 2, 1, 2 plus 1, 3 over 4 mv squared. So finally, total kinetic energy for the disc is equal to 3 over 4 mv squared. Replace 3 over 4 times mass was given 0.5. Velocity of the disc also was given 1 square. Rotational kinetic energy is equal to 0.375 joule. So it is very important, very good question, and it has been brought in the Wizari exam 2 years ago, I think in 2022. Okay? So which one is correct? 0.375 joule. A is correct. Okay? Look at the short response. Can two spheres of different diameter and different mass have the same moment of inertia? Yes, of course. When does? It's very important. When does the two spheres or two objects different diameter and different mass have the same moment? Yes, if the diameter of the second sphere is half of the diameter of the first sphere and the mass of the second sphere is 4 times of the first sphere. So it means that if R2, okay, is equal to half of R1, this is not square, okay, if R2 is equal to half of R1 and M2 is equal to quadruple 4 times M1, okay. For example, two sphere, this is for the first sphere I, moment of inertia for the first sphere and moment of inertia for the second sphere. For the first sphere is equal to 2 over 5 M1 R1 square. For the second sphere is equal to 2 over 5 M2 R2 square. Now I'm going to prove these two spheres, they have the same moment of inertia, even different radius and different mass, okay. Now replace 2 over 5 with 2 over 5 cancel. M1 R1 square is remain. M2 is equal to what? 4 M1. R2 is equal to what? Half times half R1 square. Okay? M1 R1 square is equal to 4 M1 times 1 over 2 square, 1 over 4. R1 square, R1 square. Now, R1 square with R1 square cancel. M1 with M1 cancel. The moment of inertia for the first sphere over moment of inertia for the second sphere. What is remaining here? 1. 4 times 1 over 4, 1. So, it means that these two spheres are equal in moment of inertia, even they are different in the diameter or the radius and mass. Okay? So when does the two spheres with different diameter and different mass, they have the same moment of inertia? You can say if the radius of the first ball is equal to half of its second ball, and the mass of the first ball is quadruple of the second ball. Okay? In which case, would the angular momentum be conserved when the torque on an object is 0? In that case, the angular momentum becomes conserved. Does the conservation of angular momentum lead to conservation of the rotational kinetic energy? No, because maybe the work done on a body will convert it into rotational kinetic energy without an external torque. So, according to this equation, 1 over 2 L omega. In this equation, even if the angular momentum is conserved, but rotational kinetic energy is not conserved, it is directly proportional to the angular speed, but without square. Okay? So the extended response, also this question has skipped. Okay? Skip this question. Not include this for the Wizari exam. Okay, guys, we finished chapter 2. Inshallah, in the next lesson, we are starting explaining chapter 3 and the other chapters. As I promised you, I'm going to explain the entire chapters and the whole books of the grade 12 students. Thank you for listening. Keep up your best doing. See you again, inshallah.